This section will cover the terminology and location of components. In the first compartment behind the operator's cab is the hydraulic tank with sight glass to visually check the hydraulic oil level and has a capacity of 116 gallons. The tank has the pump case drain filter, the free-fall brake coolant line filter, and the control line oil filter secured to the outside of it for good accessibility. The inside of the tank contains a pump suction filter and 2 return oil filters. Above the hydraulic tank is the air conditioner evaporator. Next is the main power divider with a visual oil level check sight glass that is used to drive the 3 Kawasaki main hydraulic pumps, free-fall coolant pump, and primary control pump. These pumps are secured to the power divider and allow adequate spacing for routine maintenance. The next area contains a Hino 8-liter engine that produces 285 horsepower that meets interim Tier 4 emission standards. The engine oil level dipstick is easily reached, and the fuel and oil filters are easily reached with drain plugs to catch the fluid securely before removal, and the fuel transfer priming pump is also easily reached. This connector is used to connect the handheld control box that operates the counterweight lifting and removal and the gantry control. This area is lined with sound dampening material to reduce engine noise. Under this cover, above the engine compartment, is the part of the Hino diesel particulate active reductive system, which is referred to as the DPR system. This muffler-type component contains the DOC, or diesel oxidizing catalyst, and the DPF, or diesel particulate filter. During operations, the DOC will be used to assist in actively burning off the trapped particulates in the filter to reduce emissions and maintain peak engine performance. Next, we have the engine coolant radiator, engine fuel cooler, engine air aftercooler, and the hydraulic oil cooler. We have removable side panels to assist in the external cleaning of these coolers. We have the coolant reservoir here. Above the coolers, we have the main engine air filter and the access panel to add water and engine oil as required. Now, starting from the front center of the machine, we have the main boom base foot pins. Below the cover, there is a Kawasaki swing motor and a swing reduction unit. There is a smaller cover that can be quickly removed to access the swing reduction unit oil levels. Mounted to the front area of these covers is the junction panel that's used to connect the attachment harnesses. Next, we have front and rear hoist drums, sometimes referred to as the main drum and auxiliary drum. They both have a rated line pull of 25,200 pounds and a maximum line pull of 46,800 pounds on the first layer by using 26 mm wire rope driven by a variable displacement Kawasaki hydraulic motor through a gear reduction unit. Both drums can produce up to 390 feet per minute of line speed with the standard hydraulic mode winch assemblies, and with the free-fall winch assemblies, the speed can be increased in the lowering direction only. Also, the braking can be controlled by foot-operated pedals with the free-fall option that actuate oil-cooled, low-maintenance brakes. The standard brakes are integrated into the hoist motors and are oil-cooled and are both controlled by the operator lever. Both drums have mechanically operated drum locks that are used for securing the drums. In the rear of the machine, we have a boom hoist drum driven by a Kawasaki hoist motor through a gear reduction unit and stopped by internal low-maintenance oil-cooled brakes. This drum contains 16 mm wire rope and can produce line speeds of up to 230 feet per minute. The drum also has an external mechanically controlled drum lock used for securing the drum. At the rear of the machine is the gantry. At the upper tip, it is equipped with sheaves that have sealed bearings that have grease fittings, and under normal operation will require greasing every 1,000 hours, or under duty cycle applications may require greasing every 500 hours. On the left side behind the door located under the steps is the storage area. In the next compartment is the solenoid control valve blocks. The second door contains the fuel tank with a capacity of 106 gallons and optional auxiliary fuel transfer pump and the power switch for the transfer pump. The switch will only work when the main key switch is in the on position. Behind this door, we have the front and rear winch motors and gear reduction units with oil level sight glasses. Below the winch motors are control valves. Next are some of the main control valves and boom hoist motor. The last compartment contains the auxiliary hydraulic oil cooler and two 12-volt batteries hooked in series to supply 24 volts of power to the machine. On the back of the upper portion of the machine is the rear counterweight assembly. It has two smaller counterweight pieces that are referred to as right counterweights and two referred to as left counterweights, and they each weigh 12,700 pounds and total 4. The counterweight tray has a weight of 18,200 pounds. When all 5 pieces are combined, the total weight is 69,000 pounds. On the lower part of the machine, we have the front and rear car body weights that weigh 15,900 pounds each. The crawler frame assemblies feature track rollers that are oil sealed and do not require greasing. The track pads have arrows cast in them to indicate the forward direction of the tracks visually from the operator's cabin to quickly remind the operator the direction the crawlers are facing. The track tension is adjusted and maintained behind an access panel using a hydraulic jack and fixed shims that maintain position of the oil-sealed front idler wheel assembly. The rear of the crawler frame contains the propel motor, propel gear reduction unit, and drive sprocket that move the fully assembled machine at 1.07 miles per hour. The complete propel assemblies are narrower than the track pads, and this aids in the prevention of damage to the assemblies from unseen obstacles during movement of the machine. The oil level in the reduction unit can be checked periodically by removing one plug and changed by removing the lower plug every 1,000 hours.